Hey everybody, this is Ripley. Welcome to the Think 2013 Math 176 course. This is a course in business calculus. I hope you enjoy it. We'll be working hard for the next 3 weeks. This may or may not be your first experience with a flipped classroom, but we'll get you through it. I promise. It's a lot of fun once you've embraced it, kind of enjoyed it. Okay, let's go ahead and get started. I'm going to work on a small page because check it out. When I go big, this thing lags, and I hate lag. So I hope you can still learn from a little old page like this. We're going to talk about functions and their graphs, okay? But the first thing that I want to plant sort of a seed in your brain is I want you to think of a quote, all right? And the quote is real valued, I did that again, valued functions of a real variable, And this is what the calculus that we're going to be dealing with, all right? And pretty much all the calculus that you're going to be dealing with until you get into more into your real and complex analysis. When we're talking about these functions, we're talking about real valued functions of a real variable. Now, I'm sure most of you guys have seen this little analogy. A function is like a machine, right? You stick an x value in here, and then out pumps a y value. And the analogy for the real valued functions of a real variable means if I stick on the real variable, this real variable right here is my x value. I take a real number, so it's got to live on the real number line. All right, grab a real number, stick it in. What comes out, the y value, is the value of the function. And that sucker's got to be real as well. Now, let me give you a quick example here of where this can fall apart on you. Let's say that f of x is equal to the square root of x minus 2, right? If I stick in f of 11, I get the square root of 9, aka positive 3. We'll get into why it's not plus and minus 3 here in just a sec. It can just be one value. Excuse me. Notice I stuck a real number in. This guy's real. And out popped a real number in terms of 3, right? Now, if I stick in f of, say, I, well, I is the square root of negative 1. It's not a real number. So if it's not a real number, I can't do calculus on it. Let's say that I stick in f of 1. If I stick in f of 1, then I get the square root of 1 minus 2, which is the square root of negative 1, which is I. Ah, crap. It's not a real number. So it doesn't work. So the calculus breaks down. So we're always playing with real valued functions of real variables. So I want you to have that quote. That it's not a definition per se. It's just a statement. I want it in your brain. All right, let's talk about what a function is. All right, a function at its absolute simplest, a function. Now I'm going to build a couple sets here, and then I'm going to make your definition. I'm going to make a set right here. I'm going to make a big set, which I'm going to call x. I'll make a big set. I'm going to call this guy y. And a function is just a rule. That's all it is a rule that assigns each little x, we're going to make this a big X, each x, which is an element, see that kind of reverse 3, that just means it lives in big X, each x in x to at most, one little y in big Y. So what I got is I take a value over here, which I'm just going to call little x, all right? And then I'm going to take a value over here, which I'm going to call little y. And what f does, f assigns values from x into y, which in this case, at its absolute simplest, watch this. Ooh, I can change colors, pretty. It just takes this guy and sends him right over here. Now, the one thing, if you've not already had this beaten, drubbed into your brain by your Algebra 2 teacher, or even your Algebra 1 teacher, the thing to remember always is that y equals f of x. However, you can also say that y equals h of x, or y equals g of x. The moral of the story is that if I take a function, f of x, or g of x, or h of x, and I think about its graph, then the x values are here. They're on the horizontal axis. And the y values are here, which in this case happens to be y equals f of x. Without getting too crazy, I could also say z of t. Let's name this guy. Now, the name of the function itself gives you a whole lot of intuition in terms of how you're going to label your axes. Now look at this, z of t. Well, Ripley told me that the y-axis is this is going to be y, which in this case is equal to z of t. It's the y-axis. Descartes said that you got an x-axis and you got a y-axis, but we can name those things differently if we want. I can call it z of t. Now here's the tricky part. This is the x-axis, but we need to start thinking of it in terms of this thing called the independent variable, which is t. Okay, so t lives here, z of t lives here. We could call this, if we wanted to, we could call this the x-axis, but we think of it in terms of t. Or it gets really confusing if you start defining things as like x of t, things like that. All right, now let's not get too crazy with stuff like that. We'll run into that down the road, but I don't want to blow everybody's mind right off the bat. Okay, so first things first, let's say that f of x is equal to y. Right? Let's identify really quickly. I'm not going to, again, you should have seen this before. X, or the value, remember this guy? The value that goes into the machine, this x guy right here, is referred to as the independent variable. This is the independent. It can be anything you want as long as it's independent, as long as it's in the domain of the function. So it's the independent variable. And y is the dependent variable. Dependent. Y is completely dependent on what? Well, think about it for a sec. This is dependent on the rule. The rule tells us what y absolutely has to be. So again, if I fumble back here, I picked 11 in this function when f of x equal to the square root of x minus 2. I picked 11 out of a hat. I kind of cheated because I wanted a nice square, so I didn't have to get too crazy right off the bat. But 11 was my independent variable. I got to pick it. It was independent of the function itself, as long as it worked, as long as it was a real value, and it was going to spit out a real value, right? The 3, this was independent. In deep, ooh, yuck, this is independent. And then this guy was completely dependent upon the rule, because had this been a different function, when I stick 11 in, had it been just x minus 2 instead of the square root of x minus 2, then this would have been 9 instead of 3. So I just want to make sure that we have all the same vocabulary. So when I throw out a phrase like, all right, you need to choose an independent variable, or what's the dependent variable, you don't freak out and be like, wow, what's he talking about? I always hated that. It's like I'd have a stranglehold on what was going on in a class, and all of a sudden my instructor would throw out a word, and I'm like, what? Here's a fun word for you, just for giggles: abscissa and ordinate. I'm not even going to define that. Maybe I'll have you guys do a little research and throw some extra credit at you. Abscissa and ordinate.